Hi, friends. My name is Odo Emmanuel from InsideSkills.com, and today we're going to be looking at artificial intelligence. There's so much buzz around artificial intelligence, machine learning, and so today we decided to look at artificial intelligence and its applications and the history. We need to talk about briefly about the architecture, about the types of artificial intelligence, their domain, and so many other things that we're going to be looking at. So we encourage you to continue with us as we run through this series. With that said, there's a popular quote from Elon Musk, and I quote, it says, "At least when there's an evil dictator, that human is going to die. But for an AI, there will be no death. It would live forever, and then you would have an immortal dictator from which we could never escape." This was what Elon Musk said because, of course, when robots take over the world, you expect that, if it were to be a human, naturally would die, but a robot can't die. So, in a nutshell, that's what it's just trying to tell us about. It's just trying to see into the future. So, what is artificial intelligence? Artificial intelligence can be said to be a man made reasoning, alludes to the creation of human knowledge in machines that are modified to think like people and copy their activities. So, of course, these machines mimic human intelligence based on the information that is being passed into it. Of course, it is data driven, and it is much of the data that has been fed into it is what is going to be acting upon. The term may likewise be applied to many machines that display characteristics related with a human brain. For example, in terms of learning and critical thinking, we've seen so many things that machines have done today, from automation, from banking to robots performing surgeries on human, so from trading, automated trading to assembly plants, machines taking over from large retail stores, automation from both ends. This is actually going to reduce the number of human workforce because robots generally is going to take over almost everything, since the world is crazy about automation. And automation is all about having machines or robots that do this task, and these tasks have been pre-programmed into these machines to be able to do both from assembly to tasks that are routine, that are done on a daily basis, like on a minute by minute, seconds by seconds, hour by hour basis. So these robots have been pre-programmed to do this thing. So basically, you can find out that the machines are actually taking over our jobs. According to Greek myth, Telios was the first animated bronze robot that was programmed to guide the island of Crete. And this was developed by a man called Hephaestus. Hephaestus, according to Greek myth, said is the god of technology. He actually invented the first robots that had life, and according to the myth, they said it had a lifeline which was a blood called the ichor, and that it is toxic to humans, that any human that come across the ichor will definitely die. So it's the blood for the gods. So, and according to Greek myth, that there was a princess that actually deceived the Telios that it was going to give it immortality, and at the end of the day, he was deceived and he died, and that was the end of the robot. So that's to show you, and this is over 450 BC, before Christ, to show you how man has been thinking and how man has been looking for alternatives to solve their day-to-day needs, from protection to automation to task being done. So ever since, people have been thinking, but nobody has been able to come up with a way forward in regards to machines actually doing real-time tasks. Not until 1950, then we had a man called Alan Turing who published a landmark paper in which it speculated about the possibility of creating machines that can think actually. So as man evolved, man started thinking in line to see if there's a way we can actually create robots that can actually mimic man's intelligence, how man thinks, have emotions, have feelings, being able to understand good from bad, evil from good. So being able to, these are what men have been envisioned. So as time evolved, the first chatbot was called Eliza and it was created in 1961. Eliza, according to history, is the modern day robot that's been, attending conferences. Is still in the first phase of artificial intelligence. Then in 2011, IBM question and answering system was developed and it defeated the world greatest Jeopardy champions. So now we're going to be looking at the stages of AI. So there are three stages actually. We have the weak AI, we have the strong AI, and we have the super intelligence AI. So the weak AI is called artificial narrow intelligence, also referred to as a weak AI. And this is the only type of AI or artificial intelligence we have succeeded up to date. Narrow AI is goal oriented, is designed to perform singular tasks, for instance, face recognition, speech recognition, voice assistance. You have driverless cars today. Searching the internet, something like Google search engine. The internet it's a place where you find examples of weak AI. Machine task. Assembly plants where instructions are being given to specific machines to do specific task. So these are the areas that these things are being applicable. Then we look at the artificial general intelligence. This is like a deeper AI. It's called a strong AI. So this concept of that mimics the human intelligence or our behaviors with the ability to learn applied its intelligence to solve any problem. Artificial general intelligence understands and acts in ways that is indistinguishable from that of humans. So this is like the step two of artificial intelligence. Machines being smart enough to be able to, tell, from good or bad, and its ability to learn on its own, to learn from its environment. For instance, we have reinforcement learning, to learn from its environment and being able to predict what's going to be the next outcome. So this is another phase of AI. Then thirdly, we look at the artificial super intelligence. It is the hypothetical AI that doesn't just mimic or understand human behavior or intelligence. This is said to be a machine that becomes self-aware and surpasses the capacity of human intelligence and our ability. So these are like super intelligent robots. For instance, we see a lot of them in our fiction movies, all these fiction films where you find you have superhumans like Superman. You have all the fiction movies that we see a lot of superheroes, that have super abilities. They can do specific things. They have emotions. Sometimes they become sober, sometimes become very outraged with the world and they want to destroy everything that comes across their way. So these are just what super intelligence. They can outrun the human reasonings, and they're just as long as in which robots can overturn the world, overthrow, they can even enslave humanity. The concept of artificial super intelligence sees AI evolve to be akin to human emotions and experience, and that it doesn't just understand them. Artificial super intelligence is where machines become self-aware and surpass the capacity of human intelligence and ability. This super intelligence has long been the muse of dystopian science fictions in which robots overrun, overthrow, and even enslaves humanity. The concept of artificial super intelligence sees AI evolved to be akin to human emotions and experience. So the whole idea is being able to have a superhuman, a super robot that can go just beyond reasoning. They have emotions, they can think, they can solve any task, they can do anything, just anything that they can imagine they can. But this is where Elon Musk was trying to tell us about the dangers of having robots, because once you have this kind of state of artificial intelligence, it means that of course these robots are going to overrun humans and they will overtake and enslave humans. Because they have the ability to do things on their own. They are no longer controlled by humans. They are super robots that think for themselves. So imagine if they can lock out the internet and decide who's going to log in and who's not going to log in on the internet. They can decide who's going to be the president of any country. They can decide who's going to live or who's going to die. They can decide who's going to get a particular operation or who's not going to get this. So until we get to that point, but this is where the AI, that's like the Ethiopia of AI. So types of artificial intelligence, we have reactive machines. This is just in the simplest form of level of robots. They cannot create memories or use information to learn or information learn to influence the future decision. So they are just basically doing based on instructions that has been fed or data that has been fed into them. So they just do those tasks based on information that is given, and they are only able to react to presently existing situations. So based on information that is being fed, it will react to that, it solve task based on information it has at its disposal. So an instance is the IBM Deep Blue, a machine that designed to play chess against a human. Is an example of this. It's just a typical example of, there are so many other examples. I'm just using this as a case study. Deep Blue evaluates pieces of a chessboard and reacts to them based on pre-coded chess strategies. It does not learn to improve as it plays, hence it is just simply reactive. That is what it means. So the next one is limited memory. So what are limited memory machines? A limited memory machine, as the name might suggest, is just able to retain some information learned from observing previous events or data. So when data is being fed into it, it uses those information. It can predict the next outcome from the pre-data that it has. So it can build knowledge using the memory in conjunction with pre-programmed data. For instance, we have the self-driving cars that store pre-programmed data in it. So based on that, it can check the lane markings and the maps alongside observing the surrounding information, such as the speed and the direction of a nearby car or the movement of nearby pedestrians. So, and it's all the street lights is going to, they will be pre-installed, be pre-programmed into the car. So they know using maps. Of course, you should be able to know the next bus stop or where to stop. You should be able to know the next zebra crossing. You should be able to know the next state junctions. You should be able to know next car's close proximity. So of course, those cars have cameras and sensors around them. So based on this information, it can predict the present and the future. It can actually tell what is going to be its next line of action, how it's going to be driving, the speed limit, the particular speed lane. Should be able to know when it should be not driving on the lane markings. Should be able to. So these are the information that has been pre-programmed into this. So this is just a typical example of limited memory. Third is the theory of mind, and this is a very powerful state of AI. Human beings have thoughts and have feelings, memories, or other brain patterns that drive and influence our behaviors. And this is based on the philosophy that theory of mind researchers work hoping to develop computers that are able to imitate the human mental models. This is the next phase of the artificial intelligence. being able to imitate the human mental models, how we think, how we reason, how we do things, being able to differentiate between right and wrong. That these machines that are able to understand that people and animals have thoughts and feelings and that can affect their own behavior. So this is like a conscious state. The the consciousness for these machines or robots. It is this theory of mind that allows humans to have social interactions and form societies. So based on this, those robots or machines can actually, interact socially, being able to know when a baby is crying and being able to be emotional when somebody is in love. These are areas that robots have not been able to actually get to that state because basically they are just pre-programmed. So, but until we get to the phase whereby these robots can actually start to have feelings, they can have emotions. Okay, so the theory of mind would be required to use the information derived from people and learn from it, which would then inform how the machine communicates, reacts to a different situation. So basically, is just having to create his own mind, being able to decide, to decipher its surrounding, being able to know what is applicable in a particular environment. If the environment is serene cool, it will behave cool. If the environment is very hostile, you should be able to know when to react, when to escape and stuff like that. So it will start to reason like we humans, how we see things, to start to mimic our human intelligence from the way our neurons, our perceptrons, our dendrites, and our axons reason, to be able to send signals to the robot's brain to tell it that okay, this place is not going to be conducive for you to stay. You need to move. Or if there are robots that have been built to like police an economy, a community, so the robot police should be able to know when to pull out a gun. You should be able to know when there's a robbery incident. You should be able to know when there's a fire incident. You should be able to know when there's just maybe a burglary, a burglar breaking into someone's house to pick up something. So basically, you should be able to know how. So basically, if there's a rape case, you don't go and shoot the person. So the robot should be able to think in line with that. Should be able to know the best, you know, decision to make at the particular situation. So when this is the fourth stage of AI, which is self-awareness. Self-awareness of AI or machines are the most complex that we might ever or be able to envision, and are described by some as the ultimate goal of AI, the utopia of AI. These are machines that have the human level consciousness and understand their existence in the world. So they are not just robots, these are super robots. These are robots that mimic human consciousness. So their conscious states, they have the conscious and the subconscious states. They can reason, they have emotions, they have feelings. They know when you are angry, they know when you are kind, they know when you are happy. They know when there's a robbery in a particular environment, and they know when to do what is right. They have conscience. They can reason like humans. They can think, but this is just like a dream because it's very difficult to achieve such a state because it means the robot is going to have its mind of its own. They don't just ask for something they need. They understand that they need something. I want a glass of water is a different statement to say, I know I want a glass of water. So these are two separate things. Being conscious of what you want and you know that this is what you want is a very serious model. Being able to develop such a conscious state of an application means requires a whole lot of work. Means these robots can reason and can think like man. It's not what is being pre-programmed. They can think of their own imaginations. They have their own senses. They can reason. As a conscious being, these machines would not just know of its own internal state, but be able to predict the feelings of others around it. So for instance, as a human, if someone yells at us, it means that person is angry, of course. So that means as the robot is going to relate with you, the robot himself can be in a sober state. He can't just come and start smiling at you because you are yelling and he's smiling. So it means he's not communicating. There's no consciousness, there's no awareness. He doesn't understand his environment, so he doesn't know what is actually happening. So without a theory of mind, we will not be able to make these inference from other humans. So this is just like another advanced level of the theory of mind, being able to be conscious. The conscious state is what differentiates we from animals. Our ability to begin to differentiate between right and wrong, our ability to be able to differentiate between good and bad, what is evil and what is right. That is what differentiates us from the lower animals. So imagine a machine being able to have this conscious state, this conscious mind, the ability to be able to think, the ability to be able to solve problems, the ability to be able to be self-aware of its environment, being able to know what is right and what is wrong, being able to be emotional. That is the utopia of machine learning or artificial intelligence. So we're going to be looking at the domain of artificial intelligence. So there are so many aspects to this, but we're going to narrow it to some specific. So just pick up specific ones which we believe it's like, for instance, it's what it's in. So of course, as research evolves, we begin to create more of this. So for instance, we'll be looking at machine learning, which is like the first state of artificial intelligence. It's just a subset of artificial intelligence. So machine learning is just a type of artificial intelligence that enables self-learning from data and then applies that learning without the need of human intervention. In actuality, there are many different types of machine learning as well as many strategies of how to best employ them or deploy them. So depending, there are so many of them, so many algorithms, but let's just narrow them to this. So we're going to be, for machine learning, we're going to be looking at these three critical states. There are three subsets: the supervised, the unsupervised, and reinforcement learning. So basically, what is a supervised learning machine learning algorithm? This is just known as a subcategory of machine learning and artificial intelligence. It is defined by its use of labeled datasets to train algorithms that to classify data or predict the outcome accurately. A common supervised learning algorithm includes your linear regression, naive Bayes, nearest neighbor, decision tree, support vector machines, and of course the neural network, which we're going to be looking at in further videos extensively. So basically, your supervised learning is all about regression and classification. Supervised learning, these are data, structured data that can predict specific outcomes because these things are pre-structured. So it's a data, maybe an existing information, a data of a particular maybe company. There are procedural steps that may be using over the years. So with such an information, you can be able to predict the future, maybe for a company that has, like for instance, a manufacturing company. Of course, they'll be very, very detailed. The entire production plant will have data from the raw material to the finished product. So of course there's hierarchy and there's a procedural way at which things are being done. So, such people have proper data. So with such data, if you pass them into this machine learning algorithm, it can help you predict the future. It can, for instance, if you have a manufacturing company, it can help you know where you can cut costs, maybe in terms of your workforce, because of course they can predict, they can help you actually automate your production, they can help you cut costs in terms of sales, they can help you, in fact, in every area these things are applicable in every facet. It helps just having big data, being able to pass in data. It should be able to predict at least accurately to a specific level. Then unsupervised learning, these are just unstructured data, untagged. They are just clusters of information data to be able to predict specific patterns. So this is just going to be looking out for pattern trends and to categorize them based on the information in clustering. This is just a type of algorithm that learns patterns from untagged data. The hope is that through mimicry, the machine is forced to build a compact internal representation of its world. Solo learning alludes deconstructing fundamental examples from an unlabeled dataset, which is unstructured. These information are not structured at all. They are just there. So, clusters of information. So what this machine does is to be able to, based on patterns, it's to just mimic through the untagged data and being able to give you with no reference at all to marked results or predictions. So there are just few strategies for unlabeled learning. Yet grouping is just by a long shot the most generally utilized solo learning strategy. Bunching alludes to the interaction of consequently gathering information and focuses with the comparable attributes and allotting them to groups. So it's just clustering, being able to sort out, just like sorting in group, being able to sort out things in groups, being able to just it will give you patterns based on what it can sieve out from groups. So it's just gonna be based, it's pattern based. Then we're gonna be looking at reinforcement learning. Reinforcement learning is a whole new paradigm shift. It's different from supervised and unsupervised learning. It's a space of AI worried about how wise specialists should make moves in a climate to amplify the thought of aggregate rewards. So the whole idea of reinforcement learning is rewards and penalization. A, an agent or the robot is able to study his environment. Once the environment is being studied, it can be able to make predictions based on the information it has been able to gather from the environment. So two things will happen. Either it gets rewarded for being able to predict positively or give a positive result, or it will be penalized based on giving a false information. So that is how this algorithm works. So it learns from its environment. So the agent learns from the environment, it gets feedback from the environment, the information it can gather. Once it gathers that information, it will be able to predict the next move. So from that, it should be able to predict positively based on the information it gathers, and it can predict positively. So even if it's been penalized, it will correct itself from the existing mistakes it has made. Deep learning is a subset of machine learning or artificial intelligence that has networks that are capable of learning from unsupervised data that is unstructured or unlabeled, also known as deep neural learning or deep neural network. The whole idea of the neural network or the deep learning is it mimics the human brain. The human brain, the way the human brain is function or is divided into several nerves. We have the dendrites and we have the axons. While the dendrites acts as the receiver of signals for the neurons, the axons act as a transmitter of the signals for the neurons. So the same way we have this has been replicated in this neural network. So we have the label, we have it's structured to mimic the way the human brain works and the way the human brain sends out information, the input, output, it has the weight, it has the bias, so many other algorithms has been factored into it. So to mimic the way the brain reasons. So that is why it is called deep learning. It is actually a superset from just machine learning because it predicts accurately based on the information that is being fed and based on the algorithms that powers it, the weights, the inputs, the bias. So depending on the kind of input you add, it give you the expected outcomes. And so many other little things, functionalities that you call into it, you'll be able to predict far, far, far more better than your normal machine learning. So which most organizations use, like it was developed deep learning, or for instance, like TensorFlow is a major platform for deep learning. It is a framework that was developed by Google engineers, and most times I think it powers their most of the algorithms. Most of the things that Google does is based on TensorFlow. It helps them in natural processing languages. It helps them in you know text and facial recognition. Anything that that is just helps to manage the entire algorithmic structure of the Google back engine. The neural network is a very, very complex application or framework or subset of artificial intelligence. Like we rightly said, the human brain is composed of over 86 billion nerve cells called neurons. They are connected to other thousands of cells by axons. Stimuli from external environment or inputs from sensory organs are accepted by dendrites. So for instance, a pure example of this is a convolutional neural network. You have generative adversarial neural network, recurrent neural networks. These are all different algorithms or methods that you can use in developing your deep learning or neural networks. We'll look at these things in depth when we start our training on artificial intelligence and machine learning. We're going to be breaking them down from subset to subset, be able to understand how these things are being applied, are applicable to real life and solving real time problems. Then we have the robotics. This is just a branch of AI which is composed of electrical engineering, mechanical engineering, computer science for designing, construction, and application of robots. Basically, of course, you need to have a physical structure. So it needs to move all those movements, all the intelligence, maybe some light sensors, it needs the electrical components, it needs the mechanical components aside from the software. And it has hardware, it has chips, they need to embed chips into it to be able to send instructions to the robot. Because if a robot, for instance, you have a working robot that can move, that can do specific tasks, there are so many other components that needs to be involved. So the mechanical, so both the balls and socket joints, it's being able to bend requires mechanical inputs. The programming, the conductors or the semiconductors that will power the mechanical input is the electrical part. So then the software part is where the instructions that will be given to those electrical sockets, like the microcontrollers, the FPGAs. These are and the sensors. These are the software parts which requires computer science. So it's an holistic thing. It's not just one side. It's not like the other machine learning that can just be, programs or instructions set to softwares. It doesn't necessarily need to be a physical device. So robots are basically, taking over the world since the advent of coronavirus. A lot of companies now, a lot of even World Health Organization have started deploying robots to sensitive areas where you have, even hospitals now use robots, to maybe fumigate, disinfect the hospitals or clinics or even parks, basically. So where people gather, where you don't have physical humans there, robots can actually go there and clean up. So even parks, eateries, a lot of people are deploying robots now. We have drones that go and deliver goods and services for e-commerce giants. We have drones that shoot videos. They have drones that news agencies now use to get real-time information and feeds. So these are all robots. So that's just it. And the advent of this thing has made life easy and has created room space for deeper penetrations. Just imagine how many just most modern films now shoot from the skies. In those days, it wasn't really possible except you are using a plane or you're recording from an helicopter. But for with drones, you can actually shoot videos from any point, any length. You can actually get return. You can use it to monitor your farm. You can use it to do so many things. So many things. The lists are endless. There are so many things that these things are applicable to. Then we have the expert systems. This is a domain in which artificial intelligence simulates the behavior and the judgment of a human or an organization containing experts. It acquires relevant knowledge from its knowledge base and interprets it as per the user's problem. The data in the knowledge base is actually added by humans, of course, who are experts in a particular domain. So this is specifically for maybe geniuses or experts, people who are the specific domain. So it's not a mass approach. It's specifically for people who have specific skill sets, to gain information, and it is used in various areas like medical diagnosis, accounting, coding, gaming, and so many areas. So this thing is applicable in diverse fields. We have fuzzy logic, and it's the method of reasoning that resembles the human reasoning. The approach of fuzzy logic is it imitates the way of decision making in humans that involves an immediate possibilities between digital values of like yes or no. The physiologic works on the levels of possibilities of inputs to achieve defined input or output, sorry. So it's pretty straightforward. It's not as complex as it sounds. Then we have the natural language processing. This is a multi-billion dollar industry on its own. The natural language processing, or NLP, refers to the AI method of communicating with an intelligent system using a natural language such as English. The whole idea is being able to have a platform that can interpret, like for instance, we have Google text to speech, you know, being able to, interpret what you want to say into vice versa, speech to text, text to speech is a typical example of natural language processing. Then, for instance, when you go to your Google search engine, you find out that as you're typing auto suggestions, these are areas where these natural language processing are actually used, and it's a very powerful tool. So for instance, Google search engine uses a lot to do prediction. So many areas where these things are being used is a very vast um, domain, and it's a very good area to So if you're enthusiastic about text to speech, or being able to transform text from Arabic to English, or English to Igbo, or to Swahili, to any language, to French, this is a specific area that you can actually venture into. Thank you for taking your time to watch this video. Please endeavor to subscribe to our YouTube channel, and please drop your comments below. Once you get feedbacks, if you want a particular videos for me to produce, just let me know in the feedbacks. Drop your comments below. Thank you, and subscribe, and please watch our next video tutorial, which is going to be the artificial intelligence in depth. Thank you.